Alright, morning, y'all. Still gonna be on vacation for a week, so I'm gonna be on this trash setup. But anyways, let's do another easy. I don't wanna take too long. This week's videos are gonna be probably a little bit lower quality. Also, we're also approaching pretty closely to almost a year. I think I started this channel like around January 15th-ish. I'm not sure. Regardless, it was pretty close to it. I can look back on the first video. I mean, actually, we could do that right now. So, I think the main thing, I'll try to, for maybe not that soon, but relatively soon, I'm gonna start doing a project. I want to start a project, but it's been difficult these days because I got vacation, it's wrapped up with finals and all that stuff. Maybe I could start a boot dev course or make a project. I'm not sure exactly. Regardless, I need to think of a project, and I don't know. I'm not the best with thinking of projects, so probably something with a back end oriented with Go, because I enjoy writing Go. Okay, let me see. How do I look at my very first video? So day one. I think day one was January 13th, actually. Yeah, anyways, let's do a quick lead code. Count negative numbers in a sorted matrix. Alright, the sortedness, maybe we could do like binary search, but can we do of n plus n? Returns a number of negative numbers in a grid. So they're sorted in descending order. Okay. Okay, so let's do n here. Grid of let's do that one. Okay. Well, okay. Actually, I don't really care. Okay, let's try the boot first. We'll try doing. I think we could do a binary search as well. Let's do this for every row in grid. I don't know why we can't do that. Maybe it might be too slow. Let's count. Return count. CNT plus equals 1 if for every if val less than 0. This is a brute force, I assume. Maybe this could work. Yeah, it probably works, right? That's too easy. Let's try but it's still like O of n plus n though, right? Alright, n times n, because that, but n plus m, that looks pretty tricky. I can probably get it to like log n, like n log n with binary search. So instead of like for every row in grid, we'll do like length of grid of 0. Like length of grid of 0, row in grid. For row in grid, okay, for every row in grid, we could do like a left, right, length of row -1, while left. I guess we can include both of the ranges, right? Inclusive. We can include both of the ranges. as valid values. So we'll do the mid here, which is just left plus right divided by 2. If mid, let's do row of mid, I guess it's negative. So what am I trying to do? So for example, I want to find this one right here, right? So we'll do dit 0, 1, 2, 3. I think we just do this here. Let's say n, because it's always gonna be the same. The length of the row is always gonna be the same. So we'll do n minus 1, right? So 0 and 1, or this is 0, 1, 2, 3, 0 to 3, and we'll do left plus that, so it'll be 3 plus 0, 3, so about will be 1 here. We'll check the current value if it's small. No, it's not, so we'll increase. I mean, if it's negative, then r equals n. Actually, let's see, I don't know actually. So like, okay, if it's not though, we can binary search. Basically, I just want to find the first, like the first negative value from, because once I could find it there, I can index it. I could do like n minus the total of that and where you are, because everything after that is negative, so it'll be 2. There are 8 negative numbers in the matrix. It's like we have a left and a right. Alright, it'll be like 3 divided by 0 divided by 2, 1.5, down, round down, so we'll do 1. So like here is the new mid. So this is positive, so we actually want to shrink our L. Yeah, that makes sense. It's not, yeah. Or like n plus mid plus 1. If it's negative, we probably overshot. Like that's probably way too big. So yeah, so L is mid minus 1. And then we'll eventually end up, since we're like always trying to find the middle, like basically the first negative number, and it'll be ending. Okay, this is wrong. It'll end up. I want right here. Right, left. We'll end up at the left, so we'll do the count. We'll do basically the index left. So like if we found this is the first negative number, 0, 1, 2, so 2, so it will be 4 minus 2. That's how many negative numbers there are. So this is the first negative number, it'll be 0. 0 minus 4, so it'll be 4 negative numbers. Exactly, so it'll be n minus left. And that's exactly, so we do binary search for every row, so that's a log n time, right? Log n, log n, log n, log n, but there's going to be n rows, so it's going to be n times n, m times log n search. So it's still not as good as this, but should be good enough. Yeah, I wonder what the optimal solution is. Ooh, okay. Okay, it's more like math manipulation. That's good enough. Alright, that's good enough for today. I'll see you guys tomorrow.